The holographic display flickered as Professor Helm adjusted the image of the crimson moth for the third time that morning. Alex watched from his seat in the back row of the xenobiology laboratory, surrounded by some of the most brilliant minds in the galaxy. The Altarian professor's 4 eyes focused on different parts of the room as he spoke, a trait that always made Alex feel like he was being watched and ignored at the same time. The Crimson Moth of Talos 7 represents one of our most challenging field assignments, Professor Helm announced, his voice carrying the weight of academic authority. These creatures possess sensory capabilities that exceed most of our detection equipment. They can sense electromagnetic disturbances from distances of up to 50 kilometers and respond to temperature variations as small as 1/10 of a degree. Alex glanced around at his classmates. Trix sat in the front row, her crystalline head formations glowing with what Alex had learned was excitement among her species. The Centauri student had already begun taking notes on her quantum tablet, the device floating beside her chair and responding to her mental commands. Behind her, 3 Quarian students shared data through direct neural links, their silicon-based forms humming softly as information flowed between them. Previous attempts to study these specimens have failed, the professor continued. The Meridian Research Institute lost 12 expeditions over the past decade. The creatures simply vanish the moment they detect any artificial presence. A holographic representation of Talos 7 appeared above the professor's desk. The forest moon rotated slowly, its surface covered in bioluminescent vegetation that pulsed with natural rhythms. Red dots marked the known locations where crimson moths had been spotted, scattered across the equatorial forest like droplets of blood on green canvas. Your assignment is simple in concept but complex in execution, Professor Helm said, his lower pair of eyes focusing directly on Alex for a moment. You must capture at least 1 live crimson moth specimen for detailed study. The creature must remain unharmed and unstressed. Standard preservation methods have proven inadequate, as the moths die within hours of capture using conventional techniques. Yuki, one of the stellar students whose energy-based form shimmed like contained lightning, raised what might have been considered a hand. Professor, what resources are available for this assignment? The Academy's full laboratory facilities are at your disposal, Helm replied. Quantum manipulation devices, temporal stasis fields, molecular restructuring equipment, and gravitational control systems. The technology budget for this assignment is effectively unlimited. Alex felt a familiar sinking sensation in his stomach. Unlimited budgets usually meant his classmates would build impossibly complex solutions that he could never hope to understand, let alone improve upon. He had learned to appreciate the Academy's advanced technology, but he still found himself thinking in terms of simpler approaches. The deadline is 14 standard days, Professor Helm continued. You will work in teams of your choosing. I expect detailed research proposals by tomorrow morning, followed by prototype demonstrations within the week. As the professor dismissed the class, Alex remained seated while his classmates formed immediate clusters around the most promising students. Trix was already surrounded by admirers, her crystalline formations now pulsing with the deep blue that indicated serious academic planning. The Quarian students had linked into a collective processing unit, their shared consciousness working on the problem at multiple levels simultaneously. Alex Chun, Professor Helm called out as the last students filed through the laboratory doors. A moment, please. Alex approached the professor's desk, trying not to feel intimidated by the Altarian's imposing presence. Helm stood nearly 3 meters tall, his elongated limbs giving him an almost insect-like appearance that seemed oddly appropriate given their current assignment. I noticed you did not join any of the forming research groups, Helm observed, his upper eyes focusing on Alex while his lower pair reviewed data on his tablet. This assignment requires considerable technical expertise. Perhaps you would benefit from collaborating with your more experienced classmates. I was thinking about working alone, Alex said, immediately regretting how defensive he sounded. I have some ideas I'd like to explore first. Ah! Helm's 4 eyes suddenly converged on Alex with an intensity that made him step backward. And what ideas might those be? Alex hesitated. His initial thoughts seemed embarrassingly simple compared to the quantum-level solutions his classmates were undoubtedly developing. Well, I was looking at the behavioral data on the moths, their feeding patterns and mating habits. I was wondering if maybe we're approaching this wrong. Wrong how? Everyone seems focused on building better traps or more advanced detection systems, Alex said, gaining confidence as he spoke. But what if the problem isn't that we need better technology? What if we need to stop using technology altogether? Professor Helm's expression was unreadable, which Alex had learned was usually not a good sign. Please elaborate. The moths flee from artificial signatures, right? Electromagnetic emissions, quantum fluctuations, anything that doesn't belong in their natural environment. But they still need to eat. They still follow their instincts. What if instead of trying to hide our technology, we just use their natural behaviors to bring them to us? You are suggesting a primitive approach, Helm said slowly. Something more akin to traditional hunting methods than scientific research. I guess so, Alex admitted. I was thinking about pheromone attraction, maybe scent-based lures. The data shows they're drawn to specific compounds in their food sources. Professor Helm was quiet for a long moment, his four eyes rotating independently as he processed Alex's suggestion. This is a course in advanced xenobiology, Mr. Chen. Our students are expected to demonstrate mastery of cutting-edge research techniques, not revert to methods that predate space travel. I understand, Alex said, but if it works... If, Helm repeated. Very well. You have my permission to pursue this approach independently. However, I expect the same level of documentation and analysis as your classmates. Failure to capture a specimen will result in course failure, regardless of your methodology. Alex nodded and gathered his materials. As he left the laboratory, he could hear the excited chatter of his classmates echoing from the corridor. They were already deep in discussions about quantum entanglement and temporal displacement, their voices filled with the enthusiasm of students who had found a worthy challenge, walking back to his dormitory. Alex pulled up the research data on his basic tablet. The crimson moths were beautiful creatures, their wings spanning nearly a meter and shifting through shades of red that had no earthly equivalent. According to the files, they fed primarily on the nectar of night-blooming flowers that grew in the canopy of Talos 7's ancient trees. The more Alex read, the more convinced he became that everyone was overthinking the problem. The moths weren't mysterious or supernatural. They were just very good at detecting artificial threats and very motivated to avoid them. But they were still insects, still driven by basic needs and instincts that had remained unchanged for millions of years. As he reached his room, Alex was already sketching preliminary designs for his trap. No quantum fields, no molecular manipulation, no technology more advanced than basic chemistry. Just an understanding of what the moths wanted and a willingness to give it to them. 3 days into the project, Alex found himself eating lunch alone in the academy cafeteria while his classmates huddled around tables, covered with holographic projections and quantum calculators. The sound of their excited planning filled the vast space, a symphony of alien languages and electronic beeping that made Alex feel more isolated than ever. You cannot be serious about using flower scents. Trix's voice carried across the cafeteria as she approached Alex's table, her crystalline formations had shifted to a pale yellow, which Alex had learned indicated amusement among her people. This is advanced xenobiology, not a children's nature class. Behind her followed Nex, a Quarian whose silicon-based form reflected the cafeteria lights like polished metal. Our preliminary calculations suggest a 97% probability. A failure for any non-technological approach, Nex stated in the flat, emotionless tone that characterized his species. The prey exhibits sophisticated evasion patterns that require equally sophisticated countermeasures. Alex looked up from his meal, a collection of earth foods that the Academy's food processors could barely approximate. Have you actually tested your calculations against real-world conditions? Testing is premature, Trix replied. settling into the chair across from Alex with movements that made crystalline chiming sounds. We are still refining our quantum phase capture matrix. The theoretical framework alone requires 67 distinct technological components operating in perfect synchronization. 67, Alex repeated. For catching a moth. For catching this moth, Nex corrected. Your failure to appreciate the complexity of the challenge explains your primitive approach. More students had begun gathering around Alex's table, drawn by what was apparently becoming the day's entertainment. Raul, a stellar student whose energy form flickered with curiosity, drifted closer. We heard about your scent trap idea, Raul said, his voice sounding like wind chimes in a gentle breeze. It is quite creative for someone from a pre-quantum civilization. Pre-quantum? Alex felt heat rising in his cheeks. Humans have been using quantum mechanics for over a century. Using basic applications, Trix clarified, her formations now cycling through shades that Alex recognized as condescending patience. We are discussing true quantum manipulation, reality modification, at the subatomic level. The ability to alter fundamental forces rather than simply observe them. Your approach, Next added, relies on chemical attraction. This is similar to methods used by primitive hunter-gatherer societies before the development of advanced technology. Alex pushed his food around his plate, trying to maintain his composure. Sometimes simple methods work better than complex ones. This statement caused what Alex could only describe as alien laughter. Trix's formations chimed like broken glass, Nex's surface rippled with what might have been mirth, and Raul's energy. Form sparked in rapid bursts. Even students from other tables had begun to look over, drawn by the obvious entertainment. Simple methods, Trix repeated, struggling to control her chiming. Yes, perhaps you could also suggest we use rocks and sticks, maybe build a fire to smoke them out. The human approach, Nex observed to the growing crowd, demonstrates the limitations of biological neural networks. Insufficient processing power leads to oversimplified solutions for complex problems. Professor Helm chose that moment to enter the cafeteria, his four eyes immediately locating the commotion around Alex's table. As he approached, the alien students quickly composed themselves, their expressions shifting to academic respectability. I trust this discussion relates to your research progress, Helm said, his lower eyes focusing on Alex while his upper pair surveyed the gathered students. We were discussing methodology, Trix replied carefully, comparing different approaches to the assignment. Indeed, Helm's attention settled fully on Alex. And how is your independent research progressing, Mr. Shan? Alex felt every eye in the vicinity focus on him. His classmates waited with barely concealed eagerness for his response, clearly expecting either failure or embarrassment. I'm making progress, he said quietly. I've identified the specific compounds that attract the moths and I'm working on delivery methods. Compounds, Next repeated for the benefit of the crowd. Chemical lures. A fascinating throwback to pre-technological hunting methods. The theoretical basis is sound, Alex said, his voice gaining strength despite his discomfort. The moths are attracted to specific nectar sources. If I can replicate those chemical signatures, they should approach voluntarily rather than fleeing from technological interference. Helm's four eyes rotated independently as he processed this information. An interesting approach, he said neutrally. Though I confess curiosity about how you plan to contain the specimens once attracted. Surely you do not intend to use primitive physical barriers. The question hit Alex harder than the mockery had. He had been so focused on attraction that he had given little thought to containment methods that would not stress the moths or trigger their escape responses. I'm still working on that part, he admitted. Of course you are. Trix's formations had shifted to deep blue, indicating scholarly superiority. The capture phase requires the most sophisticated technology. Our quantum phase matrix can create containment fields that exist partially outside normal spacetime, eliminating the stress responses that have plagued previous attempts. Partially outside spacetime, Alex repeated, to catch an insect. To catch this insect, several students corrected simultaneously. Causing another wave of alien laughter, Professor Helm raised one elongated hand, bringing immediate silence to the gathering. All approaches will be evaluated based on results, not complexity, he announced. I encourage you to focus on your own research rather than critiquing your classmates' methodologies. As Helm departed and the crowd dispersed, Alex found himself alone again with his half-finished meal. Through the cafeteria's transparent walls, he could see the Academy's research docks where supply ships arrived daily with exotic materials and advanced equipment requested by his classmates. The isolation was complete now. Study groups that had briefly considered including him had moved on to more promising partnerships. Research teams had formed around students with access to advanced fabrication facilities and quantum laboratories. Alex's simple chemical approach had become the unofficial joke of the xenobiology program. That evening, Alex sat in his small dormitory room reviewing the behavioral data on crimson moths for the 100th time. His tablet displayed feeding patterns, mating rituals, and territorial behaviors collected by automated observation posts that had managed to study the creatures from extreme distances. The data was fascinating once Alex learned to ignore the complex technological analysis that accompanied each observation. Stripped of quantum theories and electromagnetic speculation, the moths emerged as remarkably predictable creatures. They fed at specific times in specific locations, following patterns that had remained consistent across decades of observation. As Alex worked, he could hear his classmates in adjacent rooms, their excited voices discussing gravitational manipulation and temporal displacement fields. The sounds of advanced fabrication equipment hummed through the walls as they built increasingly complex prototypes. Alex opened his basic chemistry kit and began mixing compounds based on the nectar analysis from the moth's preferred food sources. The work was simple, almost meditative, compared to the frantic theoretical calculations happening around him. Each mixture was tested and refined, bringing him closer to a scent profile that might appeal to a crimson moth's natural instincts. Outside his window, the Academy's main research complex glowed with activity. Laboratories operated around the clock, their quantum fields and energy signatures creating a light show that would have impressed any technological civilization in the galaxy. Alex turned away from the window and focused on his simple tools. Tomorrow, he would need to present his research proposal to Professor Helm, and he knew exactly what kind of reception to expect. But somewhere in the back of his mind, a stubborn voice insisted that understanding was more powerful than technology, and that the simplest solution was often the best solution. He just hoped he would get the chance to prove it. The Academy's fabrication labs hummed with constant activity as teams of alien students worked around the clock on their capture devices. Alex walked through the main corridor, dodging floating platforms loaded with exotic materials and gravitational field generators that cost more than most planetary defense budgets. The scale of his classmates' projects had grown beyond anything he had imagined. Trix's team had commandeered an entire laboratory section for their quantum phase capture matrix. Through the transparent walls, Alex could see dozens of crystalline formations working in perfect synchronization, their mental links creating a collective intelligence that processed calculations at superhuman speeds. Holographic displays showed complex mathematical equations that seemed to bend reality itself, while fabrication units assembled components that flickered in and out of visible existence. The temporal displacement field requires precise quantum entanglement between 47 separate anchor points, Trix explained to a group of visiting professors who had come to observe the students' progress. We are essentially creating a pocket of accelerated time that will slow the moth's perception while maintaining normal biological function. Next door, Nex's Quarian collective had built what looked like a small starship dedicated entirely to moth capture. Their silicon-based forms moved with mechanical precision as they installed detection arrays capable of tracking quantum signatures across entire star systems. The device could apparently identify individual moths from orbit and predict their flight patterns using advanced behavioral modeling. Our approach eliminates uncertainty through complete environmental control. Nex announced to his audience. We will map every molecule in the target area and create gravitational gradients that guide the specimen toward our collection point without triggering stress responses. Alex continued past laboratory after laboratory, each one showcasing technological marvels that pushed the boundaries of known science. A team of stellar students had created energy-based containment fields that existed purely as controlled electromagnetic patterns. Another group was developing molecular restructuring devices that could modify the chemical composition of the air itself to create invisible barriers. His own workspace occupied a corner of the general-purpose laboratory, separated from the main floor by a simple privacy screen. The contrast was embarrassing. While his classmates used fabrication units that could manipulate matter at the atomic level, Alex worked with basic glassware, measuring cups, and compounds that could be found in any first-year chemistry lab. Still playing with your flour? Water? Raoul drifted past Alex's workspace, his energy form crackling with amusement. We heard Professor Helm allocated additional resources for serious projects. Perhaps you could request some actual equipment. Alex looked up from his current mixture, a combination of compounds that approximated the nectar signature of the night-blooming Telosian orchid. I have everything I need. Everything you need, Raoul repeated, his form brightening with what Alex had learned was the stellar equivalent of laughter. Chemical compounds and containers. This is your solution to one of xenobiology's greatest challenges. It might be, Alex said, continuing his work. The moths are attracted to specific scents. If I can replicate those scents accurately enough, they should approach the trap voluntarily. And then what? Raoul asked, genuine curiosity overriding his amusement. How do you contain them without technological assistance? Primitive physical barriers will trigger their escape responses immediately. Alex had been wrestling with this exact problem for days. Traditional containers would indeed stress the moths, but anything technological would repel them before they got close enough to capture. I'm working on that part, he admitted. Of course you are, Raoul drifted away. Leaving Alex alone with his thoughts and his simple tools, the containment problem had become Alex's obsession. He had studied every piece of data on crimson moth behavior, looking for patterns that might suggest a solution. The creatures were incredibly sensitive to artificial materials, but they showed no fear of natural substances that posed no immediate threat. They would land on certain types of vegetation, rest in hollowed-out tree branches, and even explore cave systems during severe weather. The answer came to Alex during his third sleepless night, while reviewing footage of moths interacting with their natural environment. In one sequence, a moth had entered a partially enclosed flower formation and remained there for several minutes. Apparently unaware that it was effectively trapped by the plant's structure, the moths did not fear containment itself, only containment that felt artificial or threatening. If Alex could create a trap that felt like a natural formation, something the moths would enter willingly and remain in comfortably, he might be able to solve both attraction and containment simultaneously. Working with renewed energy, Alex began designing what he privately called his flower trap. The structure would be simple, constructed from materials that approximated the natural substances found in the moth's environment. The scent lures would be positioned to draw the creatures into a chamber that felt like the interior of a large flower, complete with appropriate lighting and air circulation. As Alex sketched his designs and calculated chemical ratios, the sounds of advanced construction continued around him. Gravity generators powered up with deep humming sounds that made the laboratory floor vibrate. Quantum field manipulators created brief tears in space-time that appeared as dark spots in the air before immediately sealing themselves. Professor Helm made his daily rounds, stopping at each major project to review progress and offer guidance. When he reached Alex's corner workspace, his 4 eyes focused on the simple sketches and basic equipment with obvious disappointment. Your progress appears limited, Helm observed, reviewing Alex's notes with 2 eyes while the other pair examined his chemical samples. Your classmates are developing sophisticated solutions that push the boundaries of current technology. Your approach remains fundamentally unchanged from your initial proposal. I'm refining the chemical attractors, Alex explained, trying to sound more confident than he felt. I've identified the exact compounds that trigger feeding responses in crimson moths, and I'm working on optimal delivery methods. Delivery methods, Helm repeated, his tone suggesting polite skepticism. And your containment strategy? Alex hesitated, knowing how his solution would sound compared to the quantum matrices and gravitational fields being developed by his classmates. I'm designing a passive containment system that mimics the moth's natural resting spaces, something they would enter voluntarily and feel comfortable remaining in. Passive containment. Helm's 4 eyes converged on Alex with an intensity that made him step backward. You realize these creatures have evolved sophisticated escape responses. Previous capture attempts have failed precisely because conventional containment methods trigger immediate flight behaviors. Yes, sir, Alex said. That's why I'm trying to avoid anything that feels like containment. The idea is to create something that feels like shelter rather than a trap. Professor Helm was quiet for a long moment, his eyes rotating independently as he processed Alex's explanation. Around them, the sounds of advanced fabrication continued as alien students pushed the limits of galactic technology in pursuit of their quarry. Your approach is certainly unique, Helm said finally. I confess I am curious to see how you plan to compete with quantum phase matrices and gravitational manipulation using flower scents and passive barriers. As Professor Helm moved on to the next project, Alex returned to his work with renewed determination. His classmates might have unlimited budgets and impossible technology, but they were still trying to overpower their target through superior force. Alex was trying to understand it. The difference might be more important than anyone realized. By the end of the week, Alex's flower trap was complete. It looked exactly like what it was, a simple container designed to smell like nectar and feel like a safe resting place. Compared to the technological marvels surrounding it, Alex's creation appeared primitive and inadequate, but as Alex reviewed the behavioral data one more time, he felt a quiet confidence that understanding might triumph over technology. The crimson moths had survived for millions of years by avoiding artificial threats, but they still needed to eat, rest, and follow their basic instincts. Sometimes the simplest approach was the most effective approach. Alex hoped he would get the chance to prove it. The transport shuttle descended through Talos 7's atmosphere as dawn broke across the forest moon's equatorial region. Alex pressed his face against the viewport, watching bioluminescent trees fade from their nighttime glow to the soft green of morning light. Somewhere in that vast canopy, crimson moths were beginning their daily cycle, unaware that they had become the target of the galaxy's most advanced capture technologies. Professor Helm stood at the front of the shuttle, his 4 eyes scanning the assembled students and their equipment. Remember that you have exactly 1 standard day to demonstrate your capture methods, he announced. The moths are most active during the transition between day and night cycles, giving you 2 optimal windows for testing. Alex looked around at his classmates' preparations and felt his confidence waver. Trix's quantum phase capture matrix required 3 separate cargo shuttles just to transport the primary components. The device itself looked like a piece of modern art crossed with a weapon of mass destruction, its crystalline surfaces reflecting impossible angles that hurt to look at directly. The temporal displacement field will create a localized time differential, Trix explained to a cluster of recording devices that would document the test for Academy archives. The moth will experience approximately 1 minute for every hour of real time, allowing for stress-free capture and containment. Nex's gravitational manipulation system occupied an entire clearing, its massive field generators arranged in a perfect geometric pattern that could be seen from orbit. Teams of Quarian technicians made final adjustments to sensors that could detect the quantum signature of a single moth from anywhere on the forest moon. Our approach eliminates variables through complete environmental control, Nex stated with mechanical precision. We will know the location and behavioral state of every target organism within a 50-kilometer radius. The stellar students had created something that defied easy description, a pattern of controlled energy that existed in multiple dimensions simultaneously. Raoul flickered between different forms as he explained their methodology to Professor Helm. "We have learned to think like energy rather than matter," Raoul said, his voice harmonizing with itself as different aspects of his consciousness spoke in unison. "The moths cannot flee from what they cannot perceive as separate from their environment." Alex stood beside his simple trap, feeling like a child at a science fair surrounded by doctoral dissertations. His flower trap looked exactly like what it was, a basic container with holes in it that smelled like nectar. No quantum fields, no gravitational manipulation, no technology more advanced than elementary chemistry. Nervous? Dr. Yuna approached, carrying recording equipment of her own. The human xenobiologist had been assigned to document the testing process, and Alex suspected she felt as out of place among the advanced alien technology as he did. "Terrified," Alex admitted. "I keep thinking I should have tried to build something more impressive." "Impressive and effective are not always the same thing," Dr. Yuna said quietly. "Though I admit your approach is certainly unique." The testing began at midday during the moth's inactive period. Professor Helm wanted to observe the deployment and calibration of each system before the evening activity period when actual capture attempts would begin. Trix's team activated their quantum phase matrix with a sound like reality tearing apart and reforming. The air around the device shimmered with impossible colors as localized space-time bent according to their calculations. Energy readings spiked across multiple spectrums, creating interference patterns that affected equipment throughout the forest. "Temporal displacement field is stable," Trix announced, her crystalline formations glowing with satisfaction. "We are ready to begin capture operations." Nex's gravitational system powered up more quietly, but with effects that were equally dramatic. Trees in the immediate area began to lean toward the field generators as local gravity shifted according to predetermined patterns. Small objects rose from the forest floor and began orbiting the control station like tiny satellites. "Gravitational gradients are within acceptable parameters," Nex reported. "Environmental mapping is complete. We have identified 7 potential target organisms within range." The stellar students simply disappeared, their energy forms dispersing into patterns that became indistinguishable from the natural electromagnetic activity of the forest. Only their voices remained, speaking from everywhere and nowhere simultaneously. "We are the forest now," they announced. "The separation between observer and observed has been eliminated." Alex placed his simple trap in a small clearing approximately 200 meters from the nearest technological installation. The device looked absurdly primitive in its forest setting, like someone had left their lunchbox behind after a picnic. He activated the scent dispensers and checked that the passive containment system was functioning properly. "Scent lures are active," Alex reported to Professor Helm, feeling ridiculous as he spoke into his basic communicator. "Passive containment system is ready." "Passive containment," Professor Helm repeated, his tone carefully neutral. "Please describe your methodology." "For our records." Alex took a deep breath, knowing that his explanation would be preserved alongside descriptions of quantum phase matrices and gravitational manipulation. "The trap is designed to smell like the moth's preferred food sources and feel like a natural resting place. The idea is that they'll enter voluntarily and remain comfortable inside until we can retrieve them." The silence that followed his explanation was broken only by the humming of gravitational generators and the crackling of quantum fields. Alex could imagine his classmates exchanging glances of disbelief at his primitive approach. As afternoon faded toward evening, the forest began to change. Bioluminescent patterns appeared in the bark of ancient trees, and flowers that had remained closed during daylight began to open their petals. The air filled with new scents as night-blooming plants prepared for the moth's arrival. "Target organisms are showing increased activity," Nex announced from his control station. "Multiple signatures detected moving toward feeding areas." Trix's quantum matrix began generating containment fields in locations where her sensors predicted moth appearances. The fields themselves were invisible, but their effects on the surrounding environment created distinctive distortions in the air. Temporal displacement fields are positioned and ready, Trix reported. We should have multiple captures within the first hour of full activity. The stellar students remained dispersed throughout the forest, their consciousness merged with the electromagnetic patterns of the environment. They spoke in whispers that seemed to come from the trees themselves. We feel them approaching, the voices said. Beautiful creatures of living light, unaware that they fly toward scientific immortality. Alex sat beside his simple trap and waited. His chemical lures were working as intended, filling the air around the device with scents that should appeal to any crimson moth in the area. The passive containment system was ready, its flower-like interior designed to feel like safety rather than imprisonment. As the last light of day faded from the forest canopy, the first moths appeared. They were even more beautiful than the Academy's recordings had suggested, their wings spanning nearly a meter and shifting through shades of red that seemed to capture and release light like living jewels. And immediately, catastrophically, they began to flee. The quantum phase matrix detected the moth's approach and activated its temporal displacement fields. The effect was immediate and dramatic. Every moth within a kilometer radius suddenly changed direction and fled at maximum speed. The artificial time differential created energy signatures that the creature's evolved senses recognized as an existential threat. Targets are exhibiting extreme avoidance behavior, Trix reported, her crystalline formations flickering with frustration. They are moving away from all containment fields. Nex's gravitational manipulation had similar results. The moment his sensors locked onto target organisms and began adjusting local gravity to guide their flight paths, the moths scattered like leaves in a hurricane. Their sensitivity to gravitational anomalies was apparently even greater than predicted. Environmental control is triggering mass exodus behavior, Nex announced with mechanical disappointment. Targets are fleeing the operational area. The stellar students' energy-based approach proved equally counterproductive. Despite their belief that they had become indistinguishable from the forest's natural electromagnetic patterns, the moths could somehow detect their artificial consciousness and avoided those areas entirely. They sense our presence despite our camouflage, the dispersed voices admitted. Our technology leaves signatures that evolution has taught them to fear. Within an hour of peak activity time, the forest around the testing area had been cleared of crimson moths. The creatures had fled to distant regions where no artificial energy signatures could reach them, leaving the galaxy's most advanced capture technologies empty-handed. Alex watched the exodus with growing amazement. His classmates had built devices that could manipulate the fundamental forces of reality, but the moth simply flew away from anything that registered as artificial or threatening. Every technological solution, no matter how sophisticated, created signatures that the creature's evolved senses recognized as danger. As the night progressed and failure became undeniable, Alex noticed something that made his heart race with excitement. In the distance, far from any technological interference, a single crimson moth was circling his simple trap. The creature approached cautiously, drawn by scents that registered as natural food sources rather than artificial lures. Alex held his breath as the moth landed on the edge of his flower trap and began to explore its interior. The device's passive systems activated automatically, creating a gentle air current that carried additional attractant compounds while maintaining the illusion of a natural flower formation. The moth entered the trap willingly, treating it exactly like a particularly attractive feeding site. Once inside, it remained calm and unstressed, its behavioral patterns indicating comfort rather than distress. Alex's simple understanding of moth psychology had succeeded where quantum physics had failed. As dawn approached and the testing period ended, Professor Helm conducted final equipment checks with each team. The results were unambiguous. Every advanced technological solution had driven the moths away, while the simple chemical trap had achieved its objective without stress or trauma to the specimen. Alex carried his successful trap back to the shuttle, the captured moth resting peacefully inside its flower-like prison. Around him, his classmates disassembled their complex equipment in frustrated silence, unable to explain how primitive chemistry had succeeded where their advanced science had failed. The flight back to the academy was quiet, broken only by the humming of shutdown systems and the soft sounds of Alex's trap, where a crimson moth continued to behave as if it were resting in its favorite flower. Sometimes the most sophisticated approach was simply the wrong approach. Alex was beginning to understand that intelligence was not about building the most complex solution, but about finding the most effective one, the Academy's main lecture. Hall had never been as quiet as it was when Alex walked to the front carrying his simple flower trap. Every seat was filled with students, professors, and researchers who had come to witness what was already being called the most significant upset in xenobiological research history. The crimson moth inside the trap continued its peaceful behavior, occasionally moving between the scented chambers but showing no signs of stress or captivity trauma. Professor Helm stood at the podium, his four eyes reflecting a mixture of academic confusion and genuine curiosity. Behind him, holographic displays showed the comparative results from the field test, multiple technological failures, versus one successful capture using methods that predated space travel. Ladies, gentlemen, and diverse consciousness forms. Professor Helm began, his voice carrying across the packed auditorium. We are gathered to examine an outcome that challenges fundamental assumptions about the relationship between technological advancement and problem-solving effectiveness. Alex placed his trap on the demonstration table, its simple construction looking almost absurd under the Academy's advanced lighting systems. The captured moth moved lazily between feeding chambers, completely unaware that it had become the center of galactic academic attention. Student Alex Chun will present his methodology, Professor Helm announced. Following his presentation, we will conduct a detailed analysis of why advanced technological approaches failed while primitive chemical attraction succeeded. Alex stepped forward, feeling every eye in the auditorium focus on him. 3 weeks ago, these same students had laughed at his suggestion to use scent-based lures. Now they sat in stunned silence, trying to understand how their quantum matrices and gravitational manipulators had been outperformed by flower water and basic chemistry. The key was understanding what the moths actually wanted, Alex began, his voice gaining strength as he spoke. Everyone focused on building better traps, but nobody asked why the moths needed to be trapped in the first place. He activated a simple holographic display showing behavioral data on crimson moths. The images were basic compared to the quantum-rendered presentations his classmates typically delivered, but they clearly illustrated the creature's natural patterns and instincts. Crimson moths have evolved to detect and avoid artificial signatures because artificial usually means dangerous, Alex continued. But they still need to eat, rest, and follow their basic biological drives. Instead of fighting against their evolved instincts, I decided to work with them. Trix raised one crystalline appendage, her formations flickering with what Alex had learned was confused curiosity. But your approach ignores technological capabilities that could have enhanced effectiveness exponentially. Why limit yourself to primitive methods when advanced solutions were available? Because the advanced solutions were causing the problem, Alex replied. Every piece of technology you used created signatures that told the moths to flee. The more sophisticated your approach, the more threatening it appeared to creatures that had spent millions of years evolving to avoid exactly those kinds of artificial signatures. Nex's silicon surface rippled as his collective consciousness processed this information. Our calculations indicated that superior technology should overcome biological evasion patterns through brute force effectiveness. Your calculations were right about the technology, Alex said, but they didn't account for the moth's perspective. You were trying to catch creatures that evolution had specifically designed to escape from anything artificial. A murmur ran through the audience as the implications began to sink in. Professor Helm leaned forward, his four eyes focusing intently on Alex. Are you suggesting that technological advancement can actually reduce effectiveness in certain scenarios? I'm suggesting that the right tool for the job isn't always the most advanced tool, Alex replied. Sometimes understanding your target is more important than overpowering it. Dr. Yuna stood up from her seat in the faculty section. Could you elaborate on your containment methodology? Previous attempts to capture crimson moths resulted in specimen death within hours due to stress responses. Alex gestured toward his trap, where the moth continued its peaceful movements. I didn't try to contain it, I convinced it to stay. The trap is designed to feel like a natural shelter rather than a prison. As far as the moth is concerned, it found an exceptionally good flower and decided to rest there. For how long? Asked Rao, his energy form flickering with interest. Surely the deception cannot be maintained indefinitely. That's the beautiful part, Alex said, warming to his subject. It's not a deception. The trap provides everything the moth needs: food sources, comfortable temperature, appropriate lighting, and air circulation. From the moth's perspective, it really did find the perfect flower. The auditorium erupted in discussions as students and faculty tried to process the implications of Alex's approach. Advanced civilizations throughout the galaxy had assumed that technological superiority automatically translated to problem-solving effectiveness. Alex had demonstrated that sometimes the opposite was true. Professor Helm raised one elongated hand, bringing the auditorium back to order. The broader implications of this success extend beyond xenobiological research, he announced. We may need to reconsider fundamental assumptions about the relationship between technological capability and practical effectiveness. What do you mean? Asked a professor from the Academy's Quantum Engineering Department. Student Chin has demonstrated that highly evolved problem-solving sometimes requires restraint rather than advancement, Helm explained. His success came not from building more sophisticated technology, but from understanding when not to use technology at all. Alex watched as this concept spread through the audience like a revelation. Species that had spent millennia developing increasingly complex solutions to every problem were suddenly confronted with the possibility that simplicity might sometimes be superior to sophistication. But surely this is an isolated case, Trix protested, her formations cycling through colors that indicated intellectual distress. Advanced technology must be superior for the vast majority of applications, must it? Professor Helm's four eyes rotated as he considered the question. Or have we simply assumed that complexity equals effectiveness because our civilizations have been selected for technological advancement? Dr. Yuna stepped forward, her expression showing the excitement of a researcher who had stumbled onto something significant. This could represent a fundamental blind spot in advanced civilization thinking. We may have developed past the point where we can recognize simple solutions to complex problems. The discussion that followed lasted for hours, with faculty and students from across the galaxy's most prestigious academic institutions grappling with concepts that challenged their basic assumptions about intelligence and effectiveness. Alex found himself at the center of debates about evolution, technology, and the nature of problem-solving itself. As the formal presentation ended and smaller discussions began forming throughout the auditorium, Professor Helm approached Alex with an expression of genuine respect. Student Chin, I owe you an apology. I allowed assumptions about technological superiority to cloud my judgment regarding your methodology. You weren't wrong about the technology, Alex replied. Quantum phase matrices and gravitational manipulation are incredible achievements. They just weren't the right tools for this particular job. Indeed, Helm nodded, his four eyes focusing on the successful trap. Perhaps that is the lesson here. True intelligence lies not in building the most advanced solution, but in choosing the most appropriate solution. Over the following weeks, Alex found his academic status completely transformed. The student who had been mocked for suggesting primitive approaches was now invited to present his methodology to research departments across the academy. His simple flower trap became the subject of detailed analysis as scientists tried to understand the principles behind his success. The crimson moth itself became something of a celebrity, the first of its species to be successfully captured and maintained in a stress-free environment. Researchers from dozens of species came to observe the creature's behavior and study Alex's containment methods. More importantly, Alex's success had started a broader conversation about the relationship between technological advancement and practical effectiveness. Academy courses began incorporating discussions about when simpler approaches might be superior to complex ones. The concept of human-style practical intelligence entered academic vocabulary as researchers tried to describe the mindset that had led to Alex's breakthrough. 3 months after the field test, Alex received an invitation that would have seemed impossible when he first arrived at the Academy. The Galactic Research Council wanted him to present his findings at their annual symposium, speaking to representatives from every major scientific civilization in the known galaxy. Standing in his dormitory room, looking at the formal invitation, Alex reflected on how much had changed. He had come to the Academy expecting to learn from civilizations far more advanced than humanity. Instead, he had taught them something they had forgotten in their rush toward technological sophistication. Sometimes the oldest solutions are the best solutions. The crimson moth and its flower trap continued its peaceful existence, unaware that it had sparked a revolution in scientific thinking. In a galaxy full of quantum computers and reality manipulation devices, it had taken a simple understanding of what the creature actually wanted to achieve what advanced technology could not. Alex smiled as he prepared his acceptance letter for the Galactic Research Council. He had learned that intelligence was not about building the most complex solution available, but about finding the solution that actually worked. Sometimes that meant using advanced technology, and sometimes it meant understanding that a flower-scented box was more effective than bending space-time itself. In a universe full of incredibly sophisticated problems, there was still room for elegantly simple solutions. You just had to be wise enough to recognize when simple was better than complex, and brave enough to choose effectiveness over impressiveness. The human approach to problem-solving had found its place among the stars, and the galaxy was beginning to understand that sometimes the most primitive method was actually the most advanced approach of all.